positive infinity, parentheses. Make sure you're getting your bracket and your parentheses correct, okay? So the procedure for graphing functions in this form. Step 1, identify the vertex. Step 2, make a table with the vertex at the top. Choose 2 values for x, either less than the vertex or 2 values greater than the vertex. Step 3, use the equation to find y values. Step 4, plot the points from your table and then use symmetry to plot 2 more points and draw a smooth curve. Okay, so now we're going to go through these steps. So example 1, graph the function y equals 1/2 x squared. So let's write down what our vertex form is. A parentheses x minus h squared plus k. Remember h and k are the vertex. So now what we need to do, that means our vertex is 0, 0, because there is no h value and there is no k value. So vertex 0, 0. So we could go ahead and plot that point because that's where we know the vertex is. So for 2, we're going to make a table, x and y's. It's going to go 0, 2, 3. Okay. So what we're going to do for step 3 is plug these x values into the equation. So y equals 1/2 x squared. We know the 0 is going to be 0, but 0 squared is 0. 0 times 1/2 is 0. Y equals, now we're plugging into 1/2 times 2 squared. So 2 squared is 4. 4 times 1/2 is going to be 2. So for the next one, y equals 1/2 times 3 squared. 3 squared is 9. 9 times 1/2. So that would be 4.5. Okay, so we're going to go ahead and graph those points. 2, 2, over 2, up 2, over 3, up to 4.5. So about right there. Now, it's a reflection, okay? So this is our vertex. Sorry, I'm not drawing a very good line. Just straight down the y-axis. Okay, now we're going to make a reflection of those points. Hold on, that one went away. Okay, so reflection of those points. Now it's going to look like a U, so we're going to continue the graph. All right, we're going to have to understand that whenever it looks like a U, you're going to have a minimum point. So in this case, our minimum would be this point right here because it's the lowest point. So that's a minimum. So it's 0, 0. Our vertex is 0, 0. Okay. Your axis of symmetry is going to be 0 because that's straight where the line goes down. Your domain would be negative infinity to infinity because it keeps going. We don't know where it stops. Your range is going to be from our k value, which is 0 to infinity, okay? If it goes up, remember it's going to infinity. If it goes down, it goes to negative infinity. All right, moving on to example 2. Recall what our form is. So a x minus h squared plus k. Okay, so where 2 is our h, 7 is our k. We're going to go ahead and make the table. Let's pick the points. 2, 1, 0. I'm starting with 2 because that is what our point is, okay? So you need to understand that it's always the opposite of what the sign is. So our vertex point would be 2, 7. So that point is going to be 7. So if I plugged in the number 2, so y equals negative 2 minus 2 squared plus 7. Okay, 2 minus 2 is 0. Well, 0 squared is 0. 0 in the negative still gives me 0. So all of this cancels out, and I just get 7 left. Okay, so you can always double check that to make sure you're right if you'd like. For the point x equals 1, let's plug in 1. So negative 1 minus 2 squared plus 7. So we'll leave that negative there. 1 minus 2 gives me a negative 1 squared plus 7. Negative 1 times negative 1 gives me a positive 1, but I still have this negative in front, so that is going to give me a negative 1 plus 7 to give me y equals 6. And then let's plug in our 0. Y equals negative 0 minus 2 squared plus 7. 0 minus 2 is just a negative 2 squared plus 7. So negative 2 times negative 2 gives me a positive 4, and then but I still have this negative in front, so negative 4 as still, plus 7, so negative 4 plus 7 will give me 3. I'll plot these points. Let's plot our vertex first. Let's plot the point 1, 6. And I know it's going to be reflecting across the axis of symmetry, which will be right where the vertex is. And then I have the point 0, 3. So 0, 1, 2, 3, reflecting on the same. So because it looks like an N, it opens down, we're going to have a maximum point here. That will be the point 2, 7, our vertex. Our axis of symmetry will be x equals 2. Remember, it's your k value. Okay. And then let's just do our min and our max. Our min is going, domain and range. Our domain is going to be negative infinity to infinity, always with quadratics. Our range is going to be, if it opens down, it will be negative infinity, okay, to this point right here, which is 7 bracket, okay, because it's stopping right here, and it won't go any further on the y value. All right, that's all you need to know for that one. Moving on to example 3, identify the vertex axis of symmetry, whether it's a maximum, minimum, what the point is, and the domain and range, okay? So we know that h and k here are our vertex. So our vertex is going to be negative 1. It's always opposite of what this sign is. Negative 4. That sign stays the same. So our axis of symmetry, I'm going to shorten it as AOS, is what your x equals. So x equals negative 1. Is it a minimum or is it a maximum? Well, because it's positive here, that means it's going to be a minimum, okay? So if there was a negative in the front here, it would be a maximum. If it's positive, it's going to be a minimum. And then we need to state what the domain and range is. So we know our domain is always negative infinity to positive infinity. Our range, because it opens up and A is greater than 0, it's our k value. So bracket k value, which is -4 to infinity, close parentheses. And that's how you identify all of those things. So now we're going to try it again with example 4, identifying the vertex, axis of symmetry, whether there's a maximum or minimum, and the domain and range. So we could just go ahead and write our domain because we know automatically that's -infinity to infinity with quadratic equation, with quadratic functions in vertex form. That is a parabola. Okay, so our vertex is going to be our h. If there's no k, it's automatically 0. So our point is going to be +3, 0. So our axis of symmetry is what our x value is. So that x equals 3. Is it a minimum or a maximum? This is a minimum because it's positive again. Now let's identify our range. So because it's positive, a is greater than 0, it's going to be what your k value is. So 0 to infinity, close parentheses. Okay. Few more examples here. Example 5, graph and identify the vertex, axis of symmetry, maximum or minimum, and domain and range of the function y equals x plus 2 squared minus 1. So let's start with labeling what our h and our k is, meaning our vertex is -2, -1. So we can go ahead and plot our vertex. You know automatically this is going to open up because it's positive here. It's greater than 0. So I am going to then, let's do our table. Let's do -2, -1, and 0 because our graph starts at -2. And we're doing two values greater than our vertex x. So let's go ahead and plug these in. So we already know that our point is -2, -1 for this. Let's go ahead and plug in our -1. So -1 plus 2 squared minus 1. -1 plus 2 is 1 squared minus 1. So 1 squared is 1. 1 minus 1 is 0. All right, and now we're going to plug in our zeros. So y equals 0 plus 2 squared minus 1. 0 plus 2 is 2 squared minus 1. 2 squared is 4. 4 minus 1 is 3. All right, so I'm going to go ahead and plot those 2 points, 0, 3. Remember, it's going to reflect to the other side. We'll plot our -1, 0, reflecting across our axis of symmetry, which our axis of symmetry is our x value in our vertex right here. So x equals -2. So here's our axis of symmetry at -2. Let's go ahead and make our U. Make sure you draw those areas so we know that the graph continues. Our vertex is actually a minimum because it makes the U shape. So our minimum is at -2, 1. We can just state that it's a minimum. Now we're going to do our domain and range. Domain is always -infinity to infinity for these problems. Our range is what our y value is. Since it's opening up, our y value is -1 on our vertex to positive infinity. That would be all you have to do for example 5. All right, example 6. Graph and identify the vertex, axis of symmetry, maximum or minimum, and domain and range of the function. So let's go ahead and identify our vertex, h and k. Vertex is Our vertex is positive 4, 3. That means our axis of symmetry is going to be x equals 4. So we can go ahead and plot that point. Okay, so we know our axis of symmetry is right here. Now let's go ahead and make a table. Find some other points so we know a point is, we're going to start with our axis of our vertex, the 0.43, and then we're going to do 2 less than that, so 3 and 2. Let's plug in our x equals 3. So y equals negative 3 minus 4 squared plus 3. We'll solve that. 3 minus 4 is negative 1. Negative 1 squared, so negative 1 times negative 1 gives me a positive 1 with a negative still on the outside, plus 3. So it would be negative 1 plus 3 to give me y equals 2. Now plugging in our x value of 2, so y equals negative 2 minus 4 squared plus 3. 2 minus 4 is going to give me a negative 2. Carry everything else down. So negative 2 times negative 2 gives me a positive 4. But I still have my negative in front, so it would be negative 4 plus 3, so y equals negative 1. Let's go ahead and graph these points. Make sure they're reflecting across the axis of symmetry. Plot the 0.32. Reflecting across the axis of symmetry. Okay, it's like a mirror there, okay? So now let's connect our dots, make the rest of the parabola. Okay, you should know from the very beginning that this goes down because it's a negative number right here. Okay, that is also going to tell me that I'm going to have a maximum because my vertex is the highest point. Domain, negative infinity to infinity, and range, okay? It's negative, so a is less than 0, which means it opens down, so it's going to be negative infinity to our k value, which is 3, bracket, okay? It goes from negative infinity, coming from the bottom, all the way to the negative 3, and it doesn't go any higher than that negative 3 on the y-axis. That's how you use vertex form of quadratic functions. If you guys have any need any help, make sure you join the Google Meet. Otherwise, have a great